I explained you how to solve this problem, and now we're moving on to the coding part. So basically, what we did in the previous video, we created two distance vectors. So as you can see here, I had shown you for the graph for node 1 and node 2, we created two distance vectors and initialized them with intermax, which is infinity, and then we reverse them via either DFS or BFS. So after reversal, you basically get these values, and once the values in both vectors have been filled for distance, we finally choose the minimum of these in order to get to an answer. Right, so now I'll be going over the coding part and explain to you step by step. So basically, this is our function, closest meeting node, and we provided with the vector of edges and our nodes 1 and 2. Right, so n is basically edges dot size, so that is the number of edges in our graph. Now we create two vectors, so vector in distance 1 and distance 2, and we fill it with infinity, as you can see here in our sketchpad. We filled these two with infinity. This is just the initialization part. So distance 1 and distance 2 filled with infinity. Then we create, since we are going to be traversing the graph via DFS, we're going to be covering it, we're going to be initializing visited arrays for both the nodes, node 1 and 2, and filling it with false initially, so vector bool false, this 1 and this 2. Then distance 1 and distance 2, basically the first, since the node 1 and 2 are basically already like the distance of the node itself from distance of the node from itself would be 0, so we initialize that as 0, and the rest of the entries remain infinity, so we just initialize this. Right, next we move on to calling the DFS function. So since we are now traversing the graph, we call the DFS function for both node 1 and node 2 on those nodes, and give the arrays vectors distance 1 and distance 2 and this 1 and this 2. Now we're moving on. We basically choose the min distance node as -1, because right now we have not initialized it to any other value. We just choose -1 as an arbitrary value, because we haven't yet started the algorithm here. This is the for loop, and min distance till now is int max infinity because we haven't traversed it yet. Now we move on to the main logic part. So here basically we go to for loop. We check if firstly we initialize maximum distance as an integer value, which is the maximum of the distances that we have received from our arrays. Once we basically run our DFS in distance 1 and distance 2, we will have these final distance 1 and distance 2 vectors, and we check for the maximum of these. Right, so once we've gotten the maximum, we check if minimum distance till now is greater than maximum d. Right, if the minimum distance till now, which is int max, is greater than maximum d, then we make minimum distance till now as maximum d, and minimum distance node we set as I, because our aim is to get the minimum distance node, which is basically the smallest index, right, the node with the smallest index. Right, so that was mentioned in the problem. Once we have done that, we return our minimum distance node, so that completes our function. And as for DFS, you know, it's just we've done this a lot of times, so this is the same template that we use for DFS. So the classic template we have applied DFS. We firstly mark the node which we are taking as visited. So we set this node is equal to true. Then int v is equal to edges of node. So v is basically our next node that we are going to be traveling to, or are basically the neighbor. So there would basically be a directed edge from this node to v. There would be an edge. That's why we are basically traversing it. So this is a neighbor. So there's a directed edge here. So that's why we check if v is not equal to -1. That is, if v does exist, and if it has not yet been visited. If this node has not yet been visited, then we basically set it as visited, and set the distance of v as 1 plus distance of the node, because we are covering this node, right? And this is 1 plus the distance of the previous node, right? And then we again call DFS. So this is DFS is basically recursive, so that's why we call it. So this is our recursive function, and that completes our coding part. And let me just submit it to show you whether it's passing or not, and hopefully it runs.